Okay, so we've been doing dihybrid crosses, and we've been looking at dihybrids where there were two traits that were totally separate. There were things like whether a dog barks or not and what its ears are shaped like, or that sort of thing. But there are also combinations where two different genes both affect the same trait. And we've kind of seen this with blood type, where you have the ABO blood type controlled by one gene and then the rhesus factor controlled by another gene. You could think of those as two different genes that are both controlling the your blood type. And there are some that are even more connected, such as the example they're using here is the combs on chickens, the kind of crest that they have that comes from their beak up towards the middle of their head. And there are two genes that regulate that. Now, there are not a lot of general rules for how these genes interact, so we have to spell it out for you pretty much when you have one of these. Here they're telling us that we have a dominant allele R in one gene that gives you a rose-shaped comb, and a completely different allele somewhere else that produces a P-shaped comb, this sort of thing. And if you have both of those at once, then you get something they call a walnut comb. And if you don't have either of the dominant alleles, then you get what they call a single comb, the kind of mohawk thing on the end here. So we're just going to have to follow these rules and read carefully once we get through our Punnett square. That's all there is to these. If you identify the phenotypes and genotypes of the F1 generation from a cross between, this is the good part, the parents, a homozygous rose comb and a homozygous P comb. So they say rose comb is big R something and then little p. And here they say it's homozygous. So that would make this parent big R, little p. And we cross that with homozygous P comb, which they say is little r, big P. And because they use the word homozygous, I'm going to take that to mean this. If they just said rose comb and said nothing else, we'd have to write big R question mark or big R blank, and we wouldn't know what to put in this spot, but the words homozygous are helping us out here. So we know the genotypes for both of these parents. So if we cross them, what are we going to get? What gametes do they produce? Well, this is easy. This parent only has a big R and a little p to pass on, so that's the only kind of gamete they produce. And this parent's the opposite. They can only produce little r, big P. So this is going to be a one-by-one Punnett chart. It's debatable whether you even need to do a Punnett chart for these, but I'm already halfway through it, so why not? There we go. So 100% of the chicks from these two chickens are going to look like this, or they'll have this genotype, and their phenotype will be what? They have the R and the P alleles, and when those are both present, they combine to produce walnut comb. So these should be 100% walnut. Okay, not too bad. Again, I don't think any of this is worth memorizing. Anytime that we give you this kind of interaction between two genes, we're going to have to spell out how it works because there are a lot of ways that two genes can interact, where one overrides the other or where they combine to produce something new. There wouldn't be any way to deduce this if they didn't give it to you. So these are really just about working with the information that we hand you here, and there isn't a lot of new genetic skills to be picked up. But we'll do some practice to get you used to it anyway. And let's see what comes next.